Good afternoon, students. Today topic conductometric titrations. Identify the concentrations of a given analyte in a mixture. So this titrations involves the continuous additions, of a reactant to a reaction mixtures and the documentations of the corresponding change in the electrolytic conductivity of the reaction mixtures. So this can be noted that the electrical conductivity of an electrolytic solutions is dependent on the number of free ion in the solutions and the charge corresponding to each of these ions. The principle involved in conductivity titrations follows. During a titration process, one ion is replaced with another, and the difference in the ionic conductivity of these ions directly impact the overall electrolytic conductivity of the solution. It can also be observed that the ionic conductance values vary between cations and anions. Finally, the conductivity is also dependent upon the occurrence of a chemical reactions in the electrolytic solutions. The theory behind the conductivity titrations. This type of titration state that the endpoint corresponding to the titration process can be determined by means of a conductivity measurement. For a neutralization reactions between an acid and a base, the addition of the base would lower the conductivity of the solutions initially. This is because the H plus ions would be replaced by the cationic part of the base. After the equivalence points is reached, the concentration of the ionic entity will increases. This in turn increase the conductance of the solutions. Therefore, two straight lines with opposite slopes will be obtained when the conductance values are plotted graphically. The point where these two lines intersect is the equivalence points. See, these two lines intersect at B is the equivalence point, end point. So it is used to estimate the concentrations of a given analyte solution. It involves the continuous addition of a titrant to an analyte solutions and measuring the conductance of the solutions. The conductance of the solutions depends on the number of free ions and the mobility of the ions. The conductance of the solutions can be measured with the help of the conductivity meter and conductivity cell. The endpoint of the conductivity titration is obtained by plotting a conductance versus volume of titrant graph. So, what are the chemicals required for the conductivity titrations for strong acid versus strong base? The chemical required is HCl, hydrochloric acid, sodium hydroxide. What the apparatus required to conduct to do the experiment? We need conductivity meter, conductivity cell, burette, pipette, and stirrer. So these are the instruments: conductivity meter. The red one is the conductivity cell. The beaker containing solutions is the unknown HCl solution. Okay. So we're going to take base solutions in the burette, 0.1 molar NaOH, unknown HCl in a beaker. For these titrations, the principle involved is HCl solution is titrated against a solution of sodium hydroxide. By titrating, what will happen means in HCl, the conductance of the solutions is due to the presence of H plus and Cl minus ions. Since the hydrogen ions possess the greater mobility of an ion, the greater part of the conductance. Now, when we add alkali solutions from burette to the beaker containing H plus ions. So when we add, what happens? The H plus ions are removed by combinations with the OH minus ions, forming feebly ionized water molecules, and their place is taken up by comparatively slow moving sodium ions. So the reaction is H plus Cl minus, we are taking a beaker, NaOH ions we are taking a burette. When you add NaOH to the beaker containing HCl, so what will happen? It forms the NaCl plus waters. So conductance of acid solutions prominently due to presence of H plus ions. So when you add base, removes H plus ions as undissociated H2 ion. What happens? The conductance will get automatically decreases. So after equivalence point, the H plus ions completely removed. Only the OH ions will be there. So further we are adding base, what will happen? The conductance increases due to the free OH ions. So this a procedure. So 20 ml of HCl we are taking a beaker, and the conductive cells are immersed in these solutions where it was filled with sodium nitrate solutions. Now add 0.5 ml of NaOH solutions from the burette to the beaker, measuring the conductance of the solution. We are plotting a graph conductance versus volume of the unknown solutions. Okay, what the point? The point of intersections of the interpotable line will be the end point, and the volume of alkali corresponding to this point in the volume of alkali is required to neutralize 20 ml of the acid. So this one is the calculations. We have to add 0.5 ml each up to 30 reading. The 30 reading we have to write 0, 0.5, 1, 1.5, 2, 2.5 like this, and we have to measure the conductance of the solutions. See, this one is the calculation parts. So volume of HCl we are taking is 20 ml, a normative HCl will give the normative HCl, and the volume of NaOH used. By using the graph, we will find out how much volume of NaOH and normative NaOH. This also will give. So the formula is N1 is equal to, so we are going to find out a normality of HCl. So N1 is equal to V2 N2 by V1. So normality says here N1 is equal to, we will get in a normal. To find the HCl concentrations, all of the solutions, that is 1 liter solutions, we have to multiply with the equivalent of HCl. So normative HCl, what we have find out in N1 into equivalent of HCl. So the equivalent of HCl is 36.5. So we will get the answer in graph. So the strength of given HCl is normality. The amount of HCl present in 1 liter of the given solution is graph. So this is the calculation part. We get the theory. Thank you.